So what I have here is I have my oldest vehicle. It has a coefficient of 0.818. But to find how it changes my odds, I need to take that coefficient and raise E by that coefficient. So E raised to that coefficient is the relationship in the odds, and in this case that is 2.266. What this tells me what this tells me is that for every additional year a household's oldest vehicle ages, that doesn't sound very good, but you kind of get the idea there. So basically, if you're comparing a household with a car that's maybe 6 years old versus 7 years old, okay? Or a household that's oldest vehicle is 2 years old versus 3 years old, the odds of purchasing a new vehicle increase by 2.266 times. So what we can do is, again, if we look at the odds, what we would expect is that as the oldest vehicle in a household ages, that your likelihood of purchasing a new car, or the odds of you purchasing a new car to not purchasing a new car, would increase by 2.266 times. So you become more and more likely to purchase a new car as your vehicle or your oldest vehicle in your household ages, which makes a lot of sense. What you could think about is what starts off is that if you have a vehicle that's 1 year old, your chances of purchasing a new vehicle are very, very low. So if the oldest vehicle in your house is 1 year old, the chances or the odds of you purchasing a new car start off extremely low. It may be that the probability of you purchasing a new car is starting off at 1%. Okay? You're going, well, 2.2 times sounds like a lot. Okay? Well, it kind of is, but when you're starting off at a real low base, that first year going from 1 to 2 years, it increases it some, but what it's doing is it's basically increasing it from 1% to about 2.5% maybe. Okay? So it's increasing it some, but really you're still talking about an event that has a low probability. But what's happening is as your car gets a lot older, this is starting to add up as an effect. Okay? And so somewhere around 5 to 6 years, all of a sudden, you're really starting to think about it. So when your car goes from 5 years old to 6 years old, your chances at 5 years old might have been, your odds were, I don't know, maybe 0.8. Then all of a sudden, they're increasing more and more every year. So that's what's going on with oldest vehicle. Oldest vehicle is just telling us that every year your oldest vehicle ages by, you become 2.266 times more likely, or your odds increase by 2.266 times. Any questions here? Yeah.
I just got a quick question overall. When we did the backwards regression, these numbers that we got from the SDS, we always use like a dollar sign or percent. For this, you just want us to keep what we see and just put times after it?
Yes.
Okay.
Yes, that is true. Because really where you're dealing with here is you're always dealing with odds.
Okay.
You're always predicting the odds or the likelihood of doing, in this case, purchasing a new car, or if, let's say, you were trying to talk about people and whether they're likely to smoke, but you're still always talking about what are the odds of a person or this event occurring. Okay? So that's why it's always in that unit. So the only area where it would change is here. Like here I talked about $1,000 increase in income. Here I talked about for an additional year that your oldest car is older. Okay? But you're right, down here it's always going to talk about the times. That's a good question. So our last one is, in this case, child. Child had a coefficient, B3, of 2.014. Or, if we take e and raise it to that power, so if we take the exponential, raise it to the B3 power, raise it to 2.014, this becomes 7.494. So in this case, our odds become, in this case, the exponential will be 3. Our odds will change by 7.494. Okay. So what this says, if a family has added a child to their family, okay, so either by having a child or in the process of being pregnant. So if a family has added a child, what child says is if a family has added a child to their family, the odds of them purchasing a new car are 7.494 times, or about 7.5 times more likely than the equivalent family that hasn't added a child. Okay. So in this case, what we're saying is that, let's say we have two identical families in terms of the age of their oldest vehicle and their income levels. Okay? So they're identical there. So maybe they both make $60,000 and their oldest vehicle is 6 years old. Okay? What this is saying is that the family that has added a child, the odds of them purchasing a new vehicle are 7.5 times more than that family that did not have a new child. So in this case, if maybe the odds of the family without the new child are maybe 0.5. So if the odds are 0.5 for that family that hasn't had a child, what we're saying is the odds for the family that has the child adding or purchasing a new vehicle would be 7.5 times by the 0.5 odds that we have for this family that hasn't added a child, or what that would be 3.75. So the odds